All right, so we're in day 2 of limits, and we'll still continue to use other representations to find the limit of a function. Today, specifically, we're going to use a couple of analytical techniques, and they will be the rationalizing the numerator or multiplying by creative version of 1. And then we also have maybe a common denominator that you might have, some algebra that you'd have to do. So here we go. All right, so again, I warned you that we will have times when we need to do something called rationalize the numerator, which I also call multiplying by creative version of 1. So before we begin, I want to remind you that in our limit lizard, we always try to replace or substitute the value that we're approaching in for x before we begin anything else, because that might work. It often does in many limits. So here, if I plug in or substitute the 0 in there, I get a square root of 2 minus a square root of 2 over a 0. And that results in a 0 over 0, which is called, again, indeterminate form, which doesn't mean that the limit doesn't exist. It just means that we can't determine the answer in the current form it is, indeterminate form. So we are going to proceed by doing this new method called rationalizing the numerator. And how we know what to use is we use a creative version of 1, which is called a conjugate. A conjugate, if you'll notice over there, is, first of all, the square root of x plus 2 plus root 2 over itself really equals 1. It's a very creative version of 1. And the reason I chose that is because it is the conjugate of the numerator. And the conjugate of the numerator means that we have the opposite sign in the middle. And you'll see what happens here in a moment that creates or makes the conjugate such a useful item. So what we're going to have to do to start to simplify this is to multiply out the numerator and the denominator. So when I do the numerator, it's almost like a foiling process. So we're going to take first times first and get an x plus 2, because we're going to take a root 2 x plus 2 times itself. Okay, so there's our first. And outer times outer, let me write that up here. The outer times the outer is going to be a root 2 times a root x plus 2. And the inner is going to be a minus, or a negative root 2 times the square root of x plus 2. And I want you to notice that as you combine those, you'll find out that the O and the I, the outer and the inner terms with the conjugate use, is always going to cancel out. So that's the reason we don't have any more outer and inner terms. And then finally the last gets me a negative root 2 times a positive root 2, which would be a negative root 4, which ends up with our minus or negative 2 down here. So we're now down to a much simpler process in the numerator. The denominator I don't do anything with. I just sit the x next to the new denominator. All right, so now we're going to combine the things that combine together or cancel out. And hopefully you'll notice that the 2 and the minus 2 are gone and leave me with an x on the top, an x on the bottom, and that other conjugate piece. And I hope next you'll notice that that leaves me the ability to cancel the x's out of here and leaves me with 1 over that conjugate piece, to which I am then going to substitute the 0 in again. And this time it's going to provide me with an answer of 1 over, so you're going to want to say square root of 4, and I'm going to tell you no, 1 over 2 root 2 as our final answer. So again, let me rehash what happened here. We first, in the beginning, decided that our original function, when we substituted in, got an indeterminate form. Then we noticed kind of a way that we could multiply by something up in the top and the bottom of it, a creative version of 1, to which we would end up with something that's very helpful in the multiplication process. And then we did that multiplication, and we simplified very quickly, actually, and ended up able to substitute in and finally get 1 over 2 root 2. All right, so we're going to try another one here. And that will be another conjugate that we're going to use. So let's decide what our conjugate's going to be. And you're going to look at that numerator. Well, first, I guess I should replace in to make sure that we know it's in indeterminate form. Put the 0 in both places, and hopefully you notice that we do get 0 over 0, that indeterminate form. And so I'm going to choose that conjugate wisely. Let's do that. And the conjugate is going to look an awful lot like the numerator. In fact, it's going to have the 3 plus x square rooted, but it's going to have plus a root 3. Be careful right here that you multiply the bottom by the identical item, or else you're doing something illegal algebraically. Remember, we're trying to multiply by a creative version of 1. This is very creative here, the conjugate. And how I mentioned to you before, our outer and inner are going to go in the numerator, so we only will have to worry about our first and last. So we've got limit as x approaches 0, bringing the notation along. The first times the first leaves me with a 3 plus x, because if I take a square root of something by itself, it will come out of that square root. And then the last times the last gets me square root of 9, or 3. Remember, denominator, we just sit these items next to one another. And then we see the canceling begin. Hopefully you'll notice that the 3's are gone. We're left with x in a numerator and x in the conjugate piece in the denominator. Good notation here is really important. And then we cancel the x's. And we come to here where we have a limit. Don't drop that limit notation until the moment that we replace the x with 0. And this is the moment we can drop it. So we put the 0 in there, and I get 1 over root 3 plus root 3, which is 1 over 2 root 3. Again, that conjugate's a very helpful tool in certain instances. All right, I promised you another one that would be more like a common denominator. So here I notice, again, before I begin anything, I'm going to try to plug in or substitute the 0 in for x. So it goes there and there. Looks like the numerator is 1/4 minus 1/4. And that's 0, and the denominator is also 0. So we know that we have got to do something else. It doesn't look like a conjugate question to me for the fact that there's no roots involved, which is usually a giveaway for me. So I'm going to figure out what to do with this part predominantly. So it looks like it's what's called a complex fraction. We've got a fraction divided by something else. It's a complex fraction. So we are going to multiply by the common denominator, which in the numerator part would be 4 times x plus 4. So if we get that in both pieces, I end up with 4 in the first piece, and I end up with x plus 4 in the next piece, all over that x. So here then I just do a little bit of algebraic manipulation, make sure that the subtraction is applying to both pieces after the subtraction sign. And that leads me to here. And hopefully then you notice that we have 4 subtract x subtract 4, and the 4's are gone. And we have a negative x on top, and then the 4 over x plus 4, still all divided by x. So then I decided to rewrite it a little. Instead of having the whole entire thing divided by an x, the highlighter here, instead of having a whole entire thing divided by x, I could multiply by the reciprocal. So x over 1 here, I could say that it's multiplied by 1 over x. And that leads me to know that the x's are going to cancel out and leave me with negative 1 on top and 4 times x plus 4 on the bottom. I think now we are safe to say that we're going to be able to replace that 0 in there and get an answer. So I get negative 1 over 4 times 0 plus 4, and that leads me to negative 1 over 16 as the final answer. All right, just so that you can preview, what we'll be working on in class tomorrow will be these two sections, and they're on those pages. And so if you want to get a look at those things, you can get a head start, that would be a good idea.